Page 11 of exponentials. Change the equation below so that the exponent is unknown. Make it into a variable. Okay, so I'm going to put 4 to the x equals 64. All right. Name 4 methods to solve the resulting equation. You may remember that to solve this kind of equation, the traditional method is logs. Another possibility is to graph it. Another possibility is to use the calculator. And last of all, there may be a chance to solve it with algebra. So we're going to do a lot of special cases here where they can be solved with algebra. The way you solve it with algebra is you make both sides look similar with a similar base and exponent, and then you match up the exponents. Okay? So if we have two exponent expressions equal to each other and the bases are the same, then we can equate the exponents. So like if we can take 64 and express it as a power of 4, then we can equate the exponents, okay? For example, 64 is actually equal to 8 times 8, right? 8 times 8 is equal to 2 times 4 times 2 times 4. Let's see. 2 times 2 is 4. So actually, 64 is equal to 4 times 4 times 4, which is 4 to the third. So if we make 64 equal to 4 to the third, then we know that the 3 is equal to the x, and we're done. Okay, that's basically what we're going to be doing on this page. So here we have 2 to the x equals 8. We know that 8 is equal to 2 times 2 times 2. So we could write 2 to the x equals 2 to the third. So we know that x equals 3, because they're the same exponent, same base. All right, let's do C. We know that 81 is equal to 9 times 9. We know that 9 times 9 is equal to 3 squared times 3 squared, which is 3 to the fourth. So we know that x equals 4. All right, let's go to E. We know that 1/3 is equal to 3 to the negative 1. So x is equal to negative 1. We know that 125 is equal to 5 to the third. 5 times 5 times 5 is 125. So we know that 1 over 5 to the third is 5 to the negative third. So we know that x is equal to negative 3. What about I? We know that 32 is equal to 2 to the fifth. Or, we know that 32 is 4 times 8, right? So 4 is 2 squared, 8 is 2 cubed, so it's 2 to the fifth, right? 1 over 2 to the fifth. We know that 1 over 2 to the fifth is 2 to the negative fifth. So this is a pretty complicated one. We have 2 to the x minus 2 equals 2 to the negative fifth. So we know that the exponents are equal because the bases are equal. So x minus 2 is equal to negative 5. If we add 2 to both sides, we're going to get x equals negative 3. All right. Move on to K. 7 to the x plus 1 equals 343. I don't know the factors of 343. One of them must be 7, though. I'm going to take my calculator. I'm going to take 343 and divide it by 7. I get 49. Hey, that sounds familiar. 49 is 7 times 7. So 343 is equal to 7 times 7 times 7, which is 7 cubed. So that means that x plus 1 is equal to cubed. So that means x plus 1 equals 3. Negative minus 1 minus 1, x is equal to 2. All right. Moving on to number 2. Solve for x. 8 to the x equals 32. Okay, in this case, we know that 32 is 8 times 4. it's not 8 times 8, or it's not a power of 8. So what we're going to do here is we're going to change both sides so that they have like a prime number base like we did in past pages. So for example, 8 we know is 2 cubed, right? So we're going to put 2 cubed to the x equals, and then we're going to write 32 as a power of 2. We know that's 2 to the 5th, right? So now we're going to say, okay, I'm going to multiply these two together, make an exponent, and then I have that exponent, so I know that 3x equals 5. So now I divide both sides by 3, and I know that x equals 5/3. Okay, so on this section, we're getting exponents that are not whole numbers, so that's why they're a little bit more difficult to get. So we know that 9 and 27 are related, but actually 27 is 3 times 9. It's not 9 times 9 or 9. So what we're going to do is we're going to reduce both to like prime number factors. So we're going to put 3 squared x equals 1 over 3 to the third, right? Because 3 times 9 is 3 times 3 times 3. Then we're going to express both sides as a exponent of 3, so 3 to the 2x is fine, but 3 to the third needs to be changed to 3 to the negative third. Now I can set the exponents equal to each other. So I have 2x equals negative 3, and then I can divide both sides by 2, and I get x equals negative 3/2. Okay. Oops, I wasn't supposed to, oh yeah, I did that one. Okay. E, 27 and 9. So 27 we already figured out is 3 cubed. 9 we know is 3 squared. Let's change 3 squared to 3 to the negative 2 because 3 squared is in the denominator. So we're going to put 3 to the 3x equals 3 to the negative 2. So now we know that 3x is equal to negative 2. 3x equals negative 2. So x is equal to negative 2/3. G. Now we have 4 to the x plus 2 and 128. I know that 128 is like a power of 2. If you have 128 is basically 64 times 2, right? So that's equal to 8 times 8 times 2. So that's equal to 2 to the 4th times 2 to the, no, I'm sorry, 2 to the 3rd. 2 to the 3rd times 2 to the 3rd times 2 to the 1st. So actually 128 is equal to 2 to the 7th. Okay, 2 to the 7th. Alright, so and then 4 is 2 squared. So I have 2 squared times x plus 2 exponent equals 2 to the 7th. I can multiply those together and set it equal to 7. I'm going to get 2 times x plus 2, leave the parentheses, equals 7. X plus 2 equals 7/2. Subtract 2 from both sides, and you get x equals 7/2, which is 3.5, minus 2 is 1.5. I. 4 to the 4x minus 1. So I have a 2 here. I'm going to write 4 in terms of 2, so it's going to be 2 squared to the 4x minus 1 equals 2 to the negative 1. And multiply those together, set it equal to negative 1. Now I have myself an algebra problem. So I have 2, 4x minus 1 equals negative 1. Divide both sides by 2, I get 4x minus 1 equals negative 1/2. Then I add 1 to both sides. I get 4x equals 1/2. Then I divide both sides by 4, and I get x equals 1/8. Okay. I got 1/2 x to the x plus 1 equals 8. 8 is equal to 2 to the 3rd. 1/2 is 2 to the negative 1. X plus 1. Now I'm going to set this exponent equal to that one. So negative 1 times x plus 1 equals 3. Divide both sides by negative 1. X plus 1 equals negative 3. Subtract 1 from both sides, we get x equals -4. And I think we're done.